This is a question on exponentials, essentially. This t that is varying is the exponents. So let's have a look at this. We've got that 4,200 trees were planted in 2015, and then a year later, we've got 3,948 still alive. Okay, and then we've got some sort of exponential equation that is modeling this situation, where n is the number of trees still alive t years after 2015. Write down the value of a. Well, that is, if you understand exponentials well, then that is just a starting value, and so we can just simply write down that it is 4,200. If you're less sure about that, then you can substitute in, and you could say that 4,200 is equal to a times r to the power 0. So I'm substituting in my first sort of piece of information. That's t years after the 1st of November, t would be 0 for this first one. Now r to the power of 0 is just 1, so you see in this way as well we also get that a is 4,200. So I now have that n is equal to 4,200 times r to the power of t. I don't yet know what r is, but it says show that r is 0.94. And that's what we're going to use our second piece of information, because this, a year later, is when t is equal to 1. So we can write down that 3,948 is equal to 4,200 times r to the power 1, which is just r. And now I can divide through, so I can do r is equal to 3,948 divided by 4,200. And I'm expecting this to be exactly 0.94, which it is. Okay, so we've now got an even more up-to-date equation. N is equal to 4,200 times 0.94 to the t. Now this actually is going to be exponential decay, because our base here is less than 1, so we are going to get some value of trees, and then it's going to be going down like this. Actually, the question doesn't ask about that, but it's worth having that understanding of exponential decay and what it looks like. Show that on 1st of November 2030, okay, let's just jump ahead, that is going to be when t is equal to 15. The number of trees still alive is predicted to have decreased by over 60% compared with the original. So we're going to get that, according to the equation, we're going to have that n is equal to 4,200 times 0.94 to the 15. And that gives 1660.2. Now, probably the simplest way of then showing that it's decreased by 60% is to find 60%, sorry, decreased by over 60%. So if we decrease by over 60%, that's going to mean that it's going to be 40% of the original. So find 40% of 4,200. And that's going to be, we can work that out. So we could either do 0.4 times 4,200 as multiplier, or we could do 40 and then divide by 100. Anyway, we get 1680. So we can conclude basically the result follows. Find 40%, the number has decreased by about 60%. Now, I do think it is just worth talking about one other method. For example, if it said by how many percent has it decreased by, then you wouldn't just be able to use the percent they've given you to figure it out. And so you need a more advanced method. I think it's worth talking about. And this is that the new is equal to the original times the multiplier. Now we know the new. It's we've said we figured it out. It's here we go. 1660.2, and that is equal to 4,200 times the multiplier. So we can then divide through, and the multiplier is going to be this thing on the left divided by 4,200. So bear with me. Okay, and that is 0.3952. And that is equal to 39.52%. So there's been a 60% reduction. In fact, we're much more accurate. You know, we can say that there's been a 60.5% reduction even from looking at this. So just another way of looking at the problem. In any case, we've solved it.